For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@excelhomeworkhelp.com or reach us at www.excelhomeworkhelp.com. Problem 1. A soil sampling experiment classifies soils into 5 discrete porosity values, 0.1, 0.2, 0.3, 0.4, 0.5. The experiment generates 100 samples that can be described with the following histogram. The number of samples corresponding to the 5 porosity values are 14, 37, 18, 26, 5. excelhomeworkhelp.com. Use this histogram to derive a discrete probability mass function, PMF, and cumulative distribution function, CDF, for the soil porosity. Plot the PMF and CDF on the axes provided below, or on your own if you prefer. Be sure to include a label and scale for each vertical axis. Solution 1A, Px equals 0.14, 0.37, 0.18, 0.26, 0.05. excelhomeworkhelp.com. B. What are the outcomes and sample space associated with this experiment? Solution B. Sample space is set of possible outcomes, which is 0.1, 0.2, 0.3, 0.4, 0.5. C. Compute the probabilities of the following events. Solution C. A1 equals x greater than 0.35. A2 equals x equals 0.1. A3 equals x equals 0.2 or x equals 0.3. P. A1 equals 0.31 p. A2 equals 0.14 p. A3 equals 0.55. excelhomeworkhelp.com. D. Are these events mutually exclusive? If so, show that they satisfy the third probability axiom, additivity of mutually exclusive event probabilities. Solution D. The events are mutually exclusive since the 3 events, A1, A2, and A3, do not include any common porosity values, and one soil sample cannot have 2 values of porosity. P. A1 plus A2 plus A3 equals P. A1 plus P. A2 plus P. A3 equals .31 plus 0.14 plus 0.55 equals 1. E. What are the mode, mean, and variance of your PMF? Solution E. Mode equals 0.2, mean equals 1, 0.14, plus 2. 37, plus 3, 0.18, plus 4, 0.26, plus 5, 0.05, equals 2.71. excelhomeworkhelp.com. Variance equals 1 to 2.71, 2.14, plus 2 to 2.71, 2. 37 plus 3 to 2.71, 2. 18 plus 4 to 2.71, 2. 26 plus 5 to 2.71, 2. 05 equals 1.3059. F. Write a computer program in MATLAB or in Word's pseudocode to carry out a virtual experiment that draws sets of 10 samples from the probability distribution constructed in Part A. This experiment should evaluate the probability of obtaining 5 porosities greater than 0.25 from the set of 10 porosity samples. Your program should specify how you would do the following. excelhomeworkhelp.com. 1. Use the MATLAB Uniform Random Number Generator (RAND) to generate 1,000 random replicates of 10 porosity values for each replicate. The numbers obtained from RAND should be transformed to give discrete random porosity values that follow the probability distribution derived in A. Note each the MATLAB statement RAND produces a single number distributed uniformly over the interval 0, 1, while RAND N1 produces a vector of n such numbers. 2. Count the number of replicates yielding the event B1 equals 5 porosities out of 10 are greater than 0.25. 3. Evaluate the probability of this event. Solution. Quiz 1 Problem 1 F. Excelhomeworkhelp.com rep equals 1000. Percent create matrix of random numbers randoms equals rand, nrep 10, percent using CDF, 0.25, matrix of ones where porosity greater than 0.25 greater underscore 25 equals random 0.51, percent how many in each set of 10 are greater than 0.25? Number underscore greater equals sum, greater underscore 25's 2, percent calculate probability, P5 equals sum, number underscore greater equals 5, slash nrep. This gives P5 equals 0.245. Excelhomeworkhelp.com. Problem 2. A PCB measurement at a low-cost sampling station correctly detects a violation, i.e. the measured PCB concentration exceeds a specified standard, for only 80% of the samples that are flagged as violations by a very accurate and very expensive instrument. Also, the low-cost station measurement incorrectly yields a violation for 10% of the samples that do not yield a violation at the accurate station. 15% of all samples tested at the accurate station are violations. What is the probability that the PCB concentration actually exceeds the standard if the low-cost instrument detects a violation? Solution: A equals exceeds standard, accurate instrument detects violation, B equals violation detected. Excelhomeworkhelp.com. A equals 0.15 p, B A equals 0.8 p, B A equals 0.1 p, A equals 0.85. Looking for P A B equals P A B slash P B P A B, tongue sticking out B A P A, sad face 0.8, 0.15 equals 0.12 P B equals P B A P A plus P B A P A, sad face 0.8, 0.15 plus 0.1 0.85 equals 0.205. Therefore, PAB equals 0.585. Excelhomeworkhelp.com. Problem 3. Suppose that the cost of a rail fault detection program is $150,000 per year. The probability that a fault disrupts traffic for more than one day during the year is 0.01 with the detection program and 0.05 without the program. The costs arising from a repair shutdown of 1 day or more is $4 million. Is the fault detection program worth the investment, based on the 1-day shutdown cost? Why? Solution: calculate the average yearly cost, with program, 4 times 10 to the power of $6 asterisk 0.01 plus $150,000 equals $40,000 plus $150,000 equals $190,000 without program. 4 times 10 to the power of $6 asterisk 0.05 equals $200,000. Therefore, program is worth it since the expected savings is $10,000 per year. Excelhomeworkhelp.com. Problem 4. Suppose that, at any given time, 10 oceanographic floats are dispersed at random throughout 100 cells in a square, 10 by 10 cell, grid. What is the probability that a ship traveling through a row of 10 cells will intercept more than one float, assuming that the floats do not move over the time it takes the ship to cross the 10 cells? Also, assume that a float located anywhere in the same cell as the ship is intercepted. Calculate this probability using a combinatorial approach. Use combinations, without replacement, we don't care about order. Excelhomeworkhelp.com. P1 equals 1P1 P0. P1 equals C1 10 C990 slash C 10,100 equals 0.41. P0 equals C0 10 C 1090 forward slash 10 C100 equals 0.33. P1 equals 0.26. Excelhomeworkhelp.com.